Hockey is just one of those sports, right? It's lightning fast, incredibly physical, and sometimes it just looks like pure chaos out there on the ice. But what if I told you that underneath that surface layer, a revolution is happening? A revolution that's not about bigger players or fancier sticks, it's all about data. And today we're going to pull back the curtain and see how this new playbook is literally hacking the game of hockey.
Think about it. What secrets are hiding in plain sight during a single game? What if every single pass, every body check, every split-second choice a player makes, what if all of that held a deeper pattern? What if we could see the game not just as a bunch of exciting moments, but as a complex web of probabilities? Well, guess what? Now we can.
For pretty much our entire lives, we've watched hockey through the same lens, right? We see goals, hits, saves. But data sees something completely different. It's not just a goal, it's the risk impact of the play that led to it. It's not just a random flurry of action, it's a specific event sequence. And it's not just players skating around, it's the precise player formations that can crack a defense wide open. So the question is, how on earth did we get this new superpower?
To unlock all these secrets, first, we've got to understand how we're even capturing them. It all starts with being able to see the game in a way that, frankly, is just impossible for the human eye.
Okay, so the absolute bedrock of this whole new world is the Player and Puck Tracking System, or PPT for short. You can think of this as the central nervous system for modern hockey analytics. It's capturing everything from everywhere on the ice, all in real time. So how does this tech actually work? Well, it's kind of like a three-step dance. First, you've got tiny infrared sensors embedded right into every player's jersey and even inside the puck itself. Then, step 2, you have a whole network of infrared cameras all around the arena that are tracking those sensors 60 times a second. And the result? This is the mind-blowing part. Millions and millions of data points that map every single thing that happens.
And I am not exaggerating when I say millions. We are talking about up to 1 million unique data points from just one game. That fire hose of information gives analysts this incredible ability to digitally rebuild and analyze every single moment. And as you can imagine, that has led to some really, really surprising insights.
So the first major insight tackles a debate that's as old as the game itself, the whole idea of risk. Is it better to play it safe and conservative, or do you go for that high-risk, high-reward play that could win you the game?
As the researchers put it, sports are just full of these trade-offs. It's the three-point shot in basketball, or in hockey, it's that defenseman who decides to charge deep into the offensive zone. Yeah, it could lead to a fantastic scoring chance, or it could lead to a horrible turnover that goes the other way. Well, data is finally helping us solve this puzzle.
And the tool that unlocks this is a really powerful kind of AI called distributional reinforcement learning. Now here's the key difference. Instead of just looking at what usually happens on a play, this AI models the entire range of possibilities. Think of it like an AI that has simulated millions and millions of hockey games in its mind to understand not just what's likely to happen, but every single thing that could happen.
And when you feed all that game data into this AI, the results are, well, they're just stunning. Look at these charts. Along the bottom, you have a team's tendency to take risks, and going up the side, you have how many points they got in the season. You don't have to be a statistician to see that powerful upward trend. The more calculated risks a team takes, the more they win. It is almost a perfect straight line. In fact, the correlation is 0.90. Now, for anyone who deals with statistics, you know that a correlation that high it's almost unheard of. It's an incredibly strong relationship. So this isn't just a theory anymore, it's a measurable, undeniable fact. The best teams are the ones taking the most smart risks. So here's the real kicker. Taking these calculated risks isn't just a side effect of having a bunch of talented players. The data is basically screaming at us that it's a fundamental strategy that makes a team good in the first place. But risk is just one piece of this story. Let's zoom in a little bit more.
We're moving from that big picture strategy down to the nitty-gritty, the specific patterns that actually create goals. We're going to dissect the anatomy of a perfect scoring chance.
So, using another type of AI, analysts can now look past just one individual action, like a single pass. This AI sees the game as a whole sequence, like a choreographed dance, and it learns the exact combination of passes, puck recoveries, and player movements that most often lead to a goal. And this visual just shows it all perfectly. On the left, that red heat map, that's your typical kind of scattered offensive attack. But look at the right.
That green map is what the AI flagged as the optimal formation. See how much more compact and aggressive it is? It's this tight wedge shape that's designed to create maximum pressure.
So let's break down what makes this wedge so deadly. The three forwards, they form this tight little triangle, which opens up all kinds of passing lanes and gives them better angles to shoot from. And here's the crucial part. Both defenders move way up the ice. They pinch in to keep the puck in the zone. This whole setup leads to shorter, quicker passes and faster shots. It is a repeatable, data-proven blueprint for scoring. And this brings us to maybe the single most important question in all of sports analytics. Okay, we see that good teams use these formations, but do they just happen to use them? Or do these formations actually cause good things to happen? It's so important to get this right, the difference between correlation and causation. Correlation just means two things are happening at the same time. The classic example is that ice cream sales and shark attacks both go up in the summer. But eating ice cream doesn't cause shark attacks. Causation means one thing directly causes the other. Hot weather causes more people to swim, and it causes them to buy more ice cream. So is this wedge formation just the ice cream, or is it the hot weather?
Well, to find the real answer, researchers used what's called a causal inference model. In this graph right here, this is the smoking gun. It shows the treatment effect. Basically, every single bar on this chart represents a measurable, positive boost in scoring potential that is directly caused by using these optimal formations. The whole thing is positive. This isn't just a coincidence, it's straight-up causation.
And how big is that boost? We're talking about a 15% relative gain in scoring potential. In a sport that's often decided by a single goal, a 15% edge is an absolutely massive competitive advantage.
Okay, so we've got these incredible, super powerful insights, but let's be real, they're also super complex. So how do you get this information out of a data lab and actually onto the ice? How do you make it useful for a coach in the middle of a game?
This is where the final and maybe most important piece of the puzzle comes in. It's something called explainable AI. See, a lot of AI models are what we call black boxes. They spit out an answer, but they can't tell you how they got it. Explainable AI opens that box up. It translates all those complex numbers into clear advice and, maybe most importantly, builds trust with the coaches and players who have to use it.
And check out how practical this gets. This chart shows a coach which specific player skills are the most important for success on a power play according to the AI. See that top bar? Effective stick work. Right under it, puck skills. So instead of just saying, use this strategy, the AI can tell a coach why it works and who they need on the ice to make it happen. It can say, hey coach, for this to work, we need our guys with the best offensive awareness out there. It turns a data model into a trusted advisor. You know, all of this leads to one final, fascinating thought. As data and AI get woven deeper and deeper into the fabric of the sport, from team strategy to player development to in-game calls, you really have to ask yourself, will the next Stanley Cup be won on the ice? Or will it be won on a server?